Hello friends, today we are going to see some important polymers. In last class we studied about nylon 6, nylon 6, terylene, polyethylene, polypropylene and so on. So let's start with bakelite. So bakelite is a thermosetting polymer obtained from reaction of phenol and formaldehyde. So there are two monomers involved, phenol and formaldehyde. Phenol and formaldehyde react in presence of acid and base catalyst form novolac in the first two stages. So when phenol and formaldehyde are combined, novolac is formed in the first two stages. At high temperature and high pressure in third stage, bakelite is produced. Bakelite is used in telephone instrument, kitchen wave and electric insulators. So phenol is their formaldehyde, acid or base catalyst. It forms these compounds, and when these compounds are mixed with each other, no lock is formed in the first two stages, and in the third stage, at high temperature and high pressure, bakelite is produced. The next is melamine formaldehyde polymer. Decorative tabletops like formica and plastic dinnerware are made from heat and moisture resistant thermosetting plastic called melamine formaldehyde resin. So two monomers are used, one is melamine, other is formaldehyde. Melamine and formaldehyde undergo condensation polymerization where small molecules are removed to give cross-linked melamine formaldehyde. So you can see this melamine plus formaldehyde will give this compound, and in acid hydrolysis it gives a polymer melamine formaldehyde. Cross-linked melamine formaldehyde resin is obtained. Next is Buna S rubber. So it is a elastomer which is a copolymer of styrene with butadiene. So there are two monomers used, one is styrene and another is 1,3-butadiene. Its trade name is styrene butadiene rubber. The copolymer is usually obtained from 75 parts of butadiene and 25 parts of styrene. It is vulcanized with sulfur. It is used in tire industry. So tires, vulcanized tires are generally made up of this Buna S rubber. This is styrene. Last lecture we discussed about ethene CH2 double bond CH2. So one of the hydrogen we have to replace with C6H5. And that's how styrene we can draw the structure of styrene, and this one is 1,3-butadiene. So when these two monomers are combined, we are getting Buna S rubber. Next category is neoprene. So it is a condensation polymer of chloroprene. Chloroprene is 2-chloro-1,3-butadiene. Chloroprene polymerizes rapidly in the presence of oxygen. Vulcanization of neoprene takes place in the presence of magnesium oxide. Neoprene is particularly resistant to petroleum, vegetable oils, light and heat. Neoprene is used in making hose pipes for transport of gasoline and making gaskets. It is used for manufacturing insulator cable, jackets, belts for power transmission and conveying. And the structure of the monomer is written over here. It is 2-chloro-1,3-butadiene. That is known as chloroprene. The next polymer is viscose rayon. It is a semi-synthetic fiber which is regenerated cellulose. Cellulose is a linear polymer of glucose units and has a molecular formula C6H10O5N. Cellulose in the form of wood pulp is treated with conc NaOH solution to get fluffy alkali cellulose. It is then converted to xanthate by treating with carbon disulfide, that is CS2. On mixing with dilute NaOH, it gives viscous solution which is extruded through spinnerets of spinning machine into acid bath when regenerated cellulose fibers precipitate out and solidifies. So that's how viscous rayon is generated. Next kind of polymers are biodegradable. Biodegradable polymer, first is PHBV. So what are biodegradable polymer? The polymers which are decomposed by using bacteria. Those polymers are used as biodegradable. Those polymers are called as biodegradable polymer, and they don't cause any pollution because they are degraded by bacteria. First is PHBV. It is a polymer of two bifunctional beta hydroxy carboxylic acids, namely beta hydroxy butyric acid, IUPAC name is 3-hydroxybutanoic acid, and beta hydroxy valeric acid, IUPAC name is 3-hydroxypentanoic acid. Hydroxyl group of one monomer forms ester linkage by reacting with carboxyl group of the other. Thus, PHBV is an aliphatic polyester with the name polybeta hydroxybutyrate co-beta hydroxyvalerate PHBV. PHBV is degraded by microbes in the environment, and these are the structures of monomers beta hydroxybutyric acid and beta hydroxyvaleric acid. Water molecule is removed, H from OH part and OH is from COOH. So carboxylic acids OH and alcohols H is removed, water is removed, and ultimately ester linkage is obtained in PHBV. OCH CH3 CH2 C double bond O CH CH2 CH3 CH2 C double bond O N. Next polymer, again a biodegradable polymer, nylon 2 nylon 6. It is a polyamide copolymer of two amino acid, namely glycine and epsilon aminocaproic acid. It is a biodegradable polymer. So by combining glycine and epsilon aminocaproic acid, we are getting this biodegradable polymer, which is a polyamide nylon 2 nylon 6. Then there are few commercially important polymers. First is perspex acrylic glass. Monomer is methyl methacrylate. Uses are, it is used in lenses, paint, security barrier, LCD screen, shatter resistance glass. Buna N. Monomer is 1,3-betadiene and acrylonitrile. Uses adhesives, rubber belts, shoe soles, O-rings, gaskets. Next is PVC polyvinyl chloride. Monomer is vinyl chloride. Uses water pipes, raincoats, flooring. And you can see the monomer of this. Just remove one of the hydrogen of ethene and replace that by Cl, chlorine. So CH2 double bond CHCl. Polyacrylamide. Monomer is acrylamide, CH2 double bond CH, CONH2. Uses polyacrylamide gel used in electrophoresis. Next is urea formaldehyde resin. Monomers are urea and formaldehyde. Uses unbreakable dinnerware, decorative laminates. Sixth one is galactol. Monomer is ethylene glycol and phthalic acid. Uses, it is used in plaints and lacquers. Polycarbonate, bisphenol and phosgene are the monomers. Uses electrical and telecommunication hardware, food grade plastic containers. And then last, that is thermocol. Thermocol made from air-filled thin-walled beads of polystyrene. So monomer is styrene. Styrene we structure already discussed. Uses non-biodegradable styrene, can leach when heated, therefore it is banned. So these are the commercially important polymers. Thermocol was used earlier, but nowadays it is banned because of the leaching process. So that's all from polymer chapter. Thanks for watching the video.